Hey guys, welcome back to Geometry Summer Prep. We are going to pick it back up with radicals. So let's jump into it. Okay, first off, we do have some basic vocab if you want to fill this in. So we have the parts of a radical basically right here. So typically we deal with square roots in geometry, but you may have even learned about like cubed roots and fourth roots and fifth roots, maybe even in Algebra 1. So whatever this number is right here, this is called the index, okay? And if there is no index written, like if they don't put a number there at all, it's implied that n equals 2. So it's implied that we're dealing with a square root, okay? This is just the radical symbol itself, so I just put radical right there. And then anything underneath the radical, that is actually called the radicand. I feel like you don't see that often, but if you hear that referenced, they're just talking about whatever's underneath the radical, all right? This right here just says if a radical has more than one root, the radical sign indicates only the principal or the positive root. So sometimes, like especially when you get to Algebra 2, you'll talk about like how you can have a positive or a negative value for your root, but we're just going to be looking at the positive ones here. Okay, in order to simplify square roots, which is the big topic we're going to be working with here, you have to have a good handle on perfect squares, and it's really, really good if you can memorize at least the first 12 perfect squares. So let's see if we can list them out here. The very first perfect square would be the number 1, though that doesn't really, it's not really one that we use when we simplify these, but after 1, the next perfect square would be the number 4. And now when I say a perfect square, I mean if you take the square root of this number, you get a nice whole number. So what would come after 4? Well, it would actually be 9. That would be our next perfect square if we're going in order. And the way that I easily get those numbers is I think in my head, like 1 squared gives me 1, right? 2 squared gives me 4. 3 squared gives me 9. So you can kind of start thinking in those terms to be able to list them after that. So think about what would come next. Well, it'd be whatever 4 squared gives us, right? Which would be 16. Okay, and then 5 squared would give me 25. See if we can list off as many as we can here. 6 squared would give me 36. Then it's going to go 49. Then it'd be 64. Right? 9 times 9 would give me 81. 10 squared would give me 100. 11 squared would give me 121. 12 squared would give me 144. And if you can go past that, great. This would be awesome and ideal if you could memorize all of those. Okay, so let's jump into some simplifying square roots where we're actually dealing with some perfect squares in these first set of problems right here. So number 1 just wants you to evaluate the square root of 16. Well, that's in our list of perfect squares, right? So the square root of 16 just equals the whole number 4. The end, that's it. Okay, good. The common mistake I see is kids try to leave a square root on the 4, but don't. Once you take the square root of something, then the square root goes away. You're done with that part of it. So number 2, now this one's a little bit different because there's a number on the outside here. It's almost like it has like a coefficient, right? Now, if you see a number on the outside of the radical, that means you're doing that number times the radical, okay? So I would simplify the radical first. So the square root of 121, we know that's 11, right? Because that's in our set of perfect squares. So I would write this as, let's write the 2 times the square root of 121, which equals 11. So you're really just in the end doing 2 times 11 to give you 22. And that's it for that one. Number 3. Now, this one, it's similar to number 2, but we have a much bigger number right here, 289, okay? So I recommend taking the square root of 289 in your calculator. If I pull that off to the side, square root 289, and I press enter, I get 17. Now that goes kind of off our charts here, but I mean, you can't memorize all of the perfect squares. Well, you could, it would take a while, right? But we can write this out as 6 times 17, perfect square. So point is, if it's a larger number like this, always test it out in your calculator to see if it's a perfect square first, which it was. So, and then we're just doing 6 times 17, which is going to equal 102. Okay, last one here, 3 square root 400. That's obviously a number off of our list, but take the square root of that one, and that is also a perfect square. That equals 20. So this one just becomes 3 times 20 to give us 60. So that's how we handle perfect squares. Let's look at simplifying non-perfect square roots. This is what you're going to have to do a lot this year in geometry. So they give you the directions right here. Let's kind of read through them. So step number 1 says, find the largest perfect square that the radicand is divisible by, and then break down the radical using that number. Okay, and then I'll guide it from there. So the biggest thing, and there's a lot of ways to simplify radicals, y'all. You may have learned it a different way. I have taught it 2 major ways. And the way I'm going to teach you, I promise you, is the most efficient method, especially when you get to larger perfect squares. So if you've learned it a different way, it's good to know multiple ways, but I would say try to shift your focus and try to really learn it this way, because this will be the most helpful the higher up in math that you go. So we're going to do this by finding the largest perfect square that goes into this number. So let's zoom in here. So square root of 32. What I recommend, I have the perfect squares written above, right? But I would write them off to the side. Now we don't really need 1, so I always start with writing 4. I'm just going to kind of list them out. So what do we have? 4, then it goes 9, then it goes 16, 25, 36. I would just jot down some of them. What comes after that? 49, 64. I have to think about it too, right? 81. etc. Okay, we'll just leave that little list off to the side right here. So what I want to do, y'all, is I want to basically take the number that's inside the square root and divide it by these numbers, my perfect squares. But I want to find not just any number that goes into it, I want to find the largest one that goes into 32. Okay, so what I would probably do is obviously I'm not going to divide 32 by 81. 81's not going to go evenly into 32. It'd have to be a number less than 32 itself, right? Specifically, it'd have to be like less than half of 32. So I strategically would probably like kind of cut it off right here. Like 25 is less than 32, but it's not going to go in evenly. So I wouldn't even try that. I would kind of think to maybe like cut it off right there and start dividing it by these numbers, 16, 9, 4. Remember, I wouldn't go the other way. I wouldn't start with the 4 because you want to find the largest number that goes into 32. As long as you find the largest one, you're almost done. It's really like one more step after that, okay? So I would take your calculator and I would enter like 32 divided by 16, right? 32 divided by 16. Oh, look at that. It equals 2. So the first one we tried worked out. So this is what I do from there. We don't have to divide it by any others because we just found the largest perfect square that'll go into it. So we're going to branch it out and say, okay, that's 16 times 2. And I keep them both inside of square roots because technically we're taking a square root and breaking it into 2 other square roots multiplied, okay? So this is the last step pretty much. Take the square root of your perfect square. So I know the square root of 16 is just the number 4. So I evaluate that one. And then the square root of 2, the one that you can't take the square root of and get a nice whole number, you leave inside the radical, and then that is your final answer. That's it. So the hardest thing is just figuring out which number divides into it, the largest one, but from there, it's really only like one more step. All right, let's try it with the square root of 180. Zoom out a little bit. Okay, square root of 180. So again, my thought process, and you might want to list out more of these. You know what? Why don't I list the next one? 100 would come next. Okay, 121, 144. Why not? Okay, so if I look at the square root of 180, where would I start with that? Well, I know half of 180, and if you don't know half of 180, you can just do 180 divided by 2, right? But that's 90, so it's going to be a number less than 90. So I would kind of make this my cutoff, and I'd start dividing it by those numbers, right? I also kind of want to show you a trick because this can take a while, right? We want to find the largest one of these that go into 180. Let me show you a calculator trick. Let me pull up my calculator. Okay. So here's your graphing calculator. What I want you to do is go to this y equals button. I've already gone there. So y equals, click on that, clear anything that's in there, and we're going to type in 180. So 180, and this is the trick. You're going to hit divided by x. And the way you get the x is this button next to the green alpha, divided by x. So it should look like this, 180 divided by x. And then you're going to hit second and graph. And this is going to give you a table of values here, a very, very helpful table of values. Because what it is these are all the pairs of numbers that multiply to give you 180. So like 1 times 180, 2 times 90, 3 times 60. And you want to skim through and you want to find the largest perfect square that you can find. So for instance, like 4 times 45. Well, 4 is a perfect square, right? But maybe I can find a bigger one. And actually, if you go down one more, I can find it right here. 5 times 36. 36 is a perfect square, and you're not going to find a bigger one than that. Of course, you can kind of scroll up and down and just see, but that's going to be like our winning set of numbers right there. So 36 and 5. So this is a helpful little tool to help you on like some larger numbers. Let's go back here. So with 180, I'm going to branch that out as 36 times 5. Both of them still in square roots. Now this one, I can take the square root of that and get 6, right? Square root of 36 is just 6, so I just replace that with the number 6, and I leave the square root of 5 there. And that's it. So yeah, then it's just a bunch of practice problems here. Let's test some of these out. Let's try square root of 147. We know we're going to branch that out. We can do our little calculator trick. Let's go to it. So y equals, I'm going to clear that, 147 divided by x, second graph. And then we scroll, okay? And you'll see some negatives. You honestly don't have to worry about the negatives. Oh, look at this. Look at this, 3 and 49. That's going to be our winner right there. And that just takes some practice. But I've done this a lot, so it doesn't take me as long. So we're going to do 49 times 3, both in square roots. We can take the square root of 49. We get 7, square root 3. Okay, let's try square root 175. So if you want, go ahead and do your little calculator trick. I'm just going to do it in my actual calculator I have right here. And I happen to know that when it's numbers like this, sometimes you can kind of just tell. Look at our numbers over here. I know 25 goes into 175. Like I can just count by 25s in my head. So I immediately checked that one in my calculator. And that is the largest perfect square that goes into it. Okay, so if you branch it out, it's 25 times 7, square roots of both. So the square root of 25 is 5, so I get 5, square root 7. Okay, let's try these last two, square root of 48. And if you want to like pause the video and test it out yourself and see if you're getting the right answer, that would be awesome. I think that's great to try that. Okay, 48. I wonder what the largest perfect square is there. So I can go in my calculator. I can do 48 divided by x. Check it out. I believe it's going to be 16. So if you're trying that out, you should get 16 times 3. And if we take the square root of 16, that's just 4. So we get 4. Square root 3 would be fully simplified. Okay, last one in this section. So 2 square root 54. So let's start with just the square root 54 and break that one down. Okay, y'all go to work on your calculator. 54. I believe the biggest perfect square that goes into that, again, if you want to test this out, pause it because I know I'm going quickly through this. This breaks down to a 9 times 6. And 9 would be the largest perfect square. So let's take square roots of both. Square root of 9 is 3, so 3 square root 6. Now, just don't forget, we do have this 2 in front, and the way that we handle that in the end is we're going to bring it down, and I'm going to do 2 times anything that's on the outside here. So I'm doing 2 times the 3 to give me 6 square root 6. Fully simplified. All right, let's take a look at our second part of this. So second part with simplifying radicals is knowing how to divide with radicals. And I made 2 sections here. So the top section, these are going to divide really nicely. The bottom section, this taps into something that's a little bit more challenging, and it's called rationalizing the denominator. So let's look at this top section first, okay? And you can read through these steps to help you out if you forget, but I'm going to dive in and show you exactly how to do these. So it says, find each quotient, write your answer in simplest radical form. Number 1, we have the square root of a fraction, 49 over 100. I want to show you some things you can do with these fractions when we're taking square roots of them. Now, one thing you can do right away, anytime you have a square root of a fraction, you can basically pull it apart and make that the square root of the numerator divided by the square root of the denominator. So you can kind of just separate it into 2 parts. And if you do that, look how easy this becomes. These are both perfect squares. The square root of 49 is 7, and the square root of 100 is 10. So this all just simplifies to 7 over 10. That's it. It's the easiest way to do that type of problem. Okay, number 2 is similar, but it's not exactly the same, because if you look at the numbers involved, 8 and 32, neither of those are perfect squares, so it's not going to work out the same way if we immediately take the square root of the top divided by the square root of the bottom. But look at something that we could maybe do first. Look at just the fraction itself, 8 over 32. And I see that we can actually simplify the fraction 8 over 32. If you divide each of those numbers by 8, 8 divided by 8 would be 1. Let's simplify this. So this could simplify to 1 over, and then 32 divided by 8 would be 4. So the fraction itself simplified to 1 over 4. And now we can do what we did on the previous problem and pull it apart. So we can make it the square root of 1 over the square root of 4, and look at that. We have 2 perfect squares now. The square root of 1 is just 1, and the square root of 4 is 2. So all of that just simplifies down to 1/2. That's it. Okay, let's test out these other ones here. 3 over 16, well, that doesn't simplify, and they're not both perfect squares, but one of them is. The denominator is. So this one's slightly different. Let me show you how to work with this. Let's go ahead and pull it apart. Let's make it the square root of 3 over the square root of 16. Now, square root of 3 doesn't simplify, so I'm going to leave it like that. But the square root of 16 is a nice whole number. It is just 4. And that's actually your answer. That's it. So it's technically it's like mathematically legal to have a square root in your answer as long as it's in the numerator. If you have a square root in the denominator, that's not considered mathematically legal. So that's actually what the whole bottom section is about. If you end up with a square root in the denominator, I'll show you how to handle that. Okay, let's do the last one in this section here. All right, so let's take a look at this one. I do notice the denominator is a perfect square, so I'm not going to simplify the fraction. I could, but it's not really going to help me. I'm going to go ahead and immediately pull it apart because I can take the square root of the bottom part, and that's really all I need. So square root 7 over square root of 49 is just the number 7, and that is a legit answer because we don't have any square roots in the denominator. Okay, last section here. I did put this as a bonus section, so if you feel like you've had enough and you want to go to your practice sheet, go for it. Now the practice sheet also has some other types of problems that we didn't do here. So those are kind of extra, so if you want to look at the notes over the practice sheet and if you need some extra help with that, go for it. So I put bonus, not on the practice sheet, but it does come up later on in a different lesson. All right, so we will rationalize denominators at some point. So let's go ahead and jump in here. Oh, you know what? Let's fill in the notes thing. It says to rationalize a denominator, that just means get the square root out of the denominator. Go ahead and fill this in here. You should multiply multiply both the numerator and the denominator by the radical in the denominator. Let me explain. So number 5, this is our problem, 4 over the square root of 7. Okay, this is not an okay answer because there's a square root in the denominator. So we're going to do a weird little math trick thing, and we are going to multiply by the square root of 7 to the top and the bottom, okay? So I'm going to multiply by the square root of 7 over the square root of 7. And I know this looks really weird the first time you see it, but if you think about it, guys, think about the math behind it. If I just give you the fraction square root 7 over square root 7, that just cancels out, that just equals 1. So essentially we're multiplying a number, a fraction here, by the number 1, which doesn't change its value. It's just a different version of the number 1, right? It's just going to change the appearance of the number. So you do have to know how to multiply radicals, but that is pretty easy. So I'm going to explain that here. So if we do 4 times the square root of 7, guess what, guys? That's just 4 square root 7. Okay, if it's a regular whole number and a square root, you basically just write them side by side. You don't actually multiply the 4 and the 7 together. Now down here, if you have a square root of 7 times the square root of 7, you do multiply the 7s together because they're both inside of a square root, and you would get the square root of 49. Now let's do some simplifying, okay? Let's leave the 4 square root 7 alone, but take a look at this. What is the square root of 49? That's a nice whole number, 7. And now we have no more square root in the denominator, and that is our final answer. So that's why that little math trick always works, because if you multiply 2 of the same number square root, the square root will just end up canceling out in the end, okay? Let's try the same thing, with number 6. Okay, square root 5 over square root 2. The problem is the square root 2, because we need to get it out of the denominator. So let's do our little trick again and multiply both the numerator and the denominator by the square root of 2. All right, multiplying straight across. Now up top, we have a square root times a square root. So we can multiply the 5 and the 2 together and get the square root of 10 over, now if you think about this, square root 2 times square root 2, I'm going to do a little intermediate step and write it down here. That would equal the square root of 4, right? But then think about it. What is the square root of 4? Oh, it's just the number 2. So the square roots is simply just cancel each other out there. And that it would be final answer. Boom. All right, we only have 2 left. Let's jump in here. All right, square root of 81 over 2. So we got like a little fraction situation, and I notice 81 is a perfect square. So what I'm going to do is I'm going to immediately pull that apart to the square root of 81 divided by the square root of 2. And I think, okay, what's the square root of 81? That's 9. And then I can't take the square root of 2, so I leave that alone. But it's not my final answer because I can't have a square root in the denominator. So this is when we do our little math trick. I'm going to multiply both the top and bottom by square root 2. And multiplying straight across, 9 times the square root 2 is just 9 square root 2. And then we just did this one, right? Square root 2 times square root 2 will end up just being the number 2. It's the square root of 4, but simplifies to 2. And that would be final answer. All right, last one here. There's a couple ways you could probably go about this one. Neither of those are perfect squares. So I'm going to see if maybe I can just simplify the fraction first to deal with smaller numbers. So the square root of 6 over 18. Well, 6 goes into both numbers. I could make this 1/3. Okay, and now let's pull it apart and see what happens. So that would be the square root of 1 over the square root of 3. I can take the square root of 1, that's just 1. So I end up with 1 over the square root of 3. Can't have a square root in the denominator, so we do our little math trick. We're going to multiply both the top and the bottom by square root 3. Kind of running out of room over here. Let's see. Now up top, we're going to do 1 times the square root of 3, which is 1 square root 3, or you can drop the 1 and just put square root 3 over, now think about this, square root 3 times square root 3 would be the square root of 9, and then what is the square root of 9? It's just 3. And that's it. Okay, lots of square roots. Hopefully you followed that, and also that bonus lesson. And let's see if I can stop my screen share. Okay, great. I will see you on the practice sheet, guys.